Well then, we march onward through this look at how to integrate by hand various kinds of functions. On today's show, we look at powers of trig functions, and in particular, in this screencast, we're looking at integrals of the form sine to some power cosine to some power. Uh, there will be a separate screencast that'll deal with powers of tangent and secant, but in this screencast, we're going to look at integrals where sine is raised to a power and cosine is raised to a power. And this we handle in three cases. Case one is the case where the power on sine is odd. If the power on sine is odd, then the technique is to break off a sine x and use the fact that sine squared x is 1 minus cosine squared x. So what does that mean? Well, let's pretend, pull out the little red trolley and pretend that we want to integrate sine cubed of x cosine to the fourth of x. This is a situation where the power on sine is odd. So we're going to break off a sine x. That's going to leave us with a sine squared x. And then right out here, we're going to use sine x dx. We're going to make this function like the du. How can we do that? Well, what's the function whose derivative has a sine x in it? Cosine x has a derivative that's negative sine x. So cosine's great there, but that's not a cosine. So we use the fact that sine x is 1 minus cosine squared x. Because now, distributing, now we're in a scenario where we can do a u substitution. We would do a u substitution where u is cosine x. I don't want to be cosine x. Well, that's too bad. And du is negative sine x dx. And that means that this integral is negative integral u to the fourth minus u to the sixth du. And that's negative 1/5 u to the fifth minus 1/7 u to the seventh plus c. But they didn't give us this thing in terms of u. They gave it to us in terms of cosine x. And so this is negative 1/5 cosine to the fifth of x minus 1/7 cosine to the seventh of x plus a constant. Moral of the story, when there's a sine x to an odd power, we break off a sine x and run. What happens if m is even and n is odd? What happens in that scenario? That's this. Sine squared x cosine cubed x dx. So this is a scenario where n is odd, and the technique is that we break off a cosine x. We'll break off a cosine x, and we'll leave it right at the end. Why? Because this is going to function as du. How can this function as du? Well, if u is the sine of x, so this is fine, but this is not. Now it's okay. That's the du. This is an expression with a bunch of signs in it, which means that this, we let u be sine x, we let du be cosine x dx, and what does that give us? U squared minus u to the fourth du, which is 1/3 u cubed minus 1/5 u to the fifth plus a constant, and they didn't give us u's originally, they gave us x's originally. Oh, mercy. And so we're done. The key, again, we had an odd power, so we broke off a cosine and did a fairly straightforward u substitution. So what happens if both the power on sine and the power on cosine are even? Well, then the technique is to sub in from a double angle formula. And we know that sine squared of x is 1 minus the cosine of 2x over 2. We know that cosine squared x is 1 plus the cosine of the double angle over 2. And that's what helps us to do this. This is the integral of cosine x to the fourth power. And that's the integral of cosine squared x times cosine squared x. And so that's the integral of 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2 dx. And we'll just make things a little bit easier by factoring out the 1/4. And then this is binomial expansion. So you got a 1, you got a 2 cosine 2x, you got a cosine squared of 2x. And now we're thinking, wait a minute, this is okay. We can do this. We can do this mostly. Like, I know what the antiderivative is here. I know what the antiderivative is here. That's tricky, but we play this game again. So that's 1, that's 2 cosine 2x. This is 1 plus cosine of the double angle over 2. So let's make sure we can do this. Antiderivative of 1, got it. Antiderivative here, I hope that's okay with all my u substitution friends. And then that's okay. This is a u substitution situation plus a constant. Doesn't have to be pretty, has to be right. This is the case that we always hope the other Calc 2 section gets on their quiz, on their test. This is by far the most difficult one, and it's the most difficult one because we don't really memorize these things. They're difficult to stick in our brain somewhere, but you got to memorize them if I'm going to throw a case 3 your way. These are the only 3 cases with sines and cosines. There are no other cases with sines and cosines. So I hope that this is helpful as you go at the practice questions that are available to you.